Today we're going to be talking about the quotients of square roots. And quotient, remember, means to divide. So we are going to be dividing where there are square roots involved. In example 1 with letter A, we're taking the square root of 48 divided by the square root of 6. Now notice that these two square roots are separate, but it is okay to write that as one large square root sign. Now since 48 and 6 are divisible, and both of them have square roots, we can actually divide them. So the square root of 48 divided by the square root of 6 equals the square root of 8. Now we don't want to leave it the square root of 8 because we want our answer in simplified form, and we've learned how to break that down throughout this chapter. The square root of 8 would break down into the perfect square of 4, and then times the square root of 2. The square root of 4 is 2, so we would have 2 root 2 as our answer. In letter B, we're introducing variables where we have the square root of 54x to the 7th divided by the square root of 2x squared. Now once again, if these are divisible, go ahead and divide them because they both have square roots. So I can take 54 divided by 2, and when I do that, I get 27. And when I have my variables with my exponents, I've got x to the 7th and x squared. Well, I can go ahead and divide those, and our rule that we've learned in previous chapters is you're going to subtract your exponents. So x to the 7th divided by x squared would be x to the 5th. Now once again, we have to make sure that's simplified. 27 can break down into the square root of 9 times the square root of 3. The square root of 9 is 3, so that comes on the outside. And since I'm working with variables, I want to leave a little bit of space, and I'm going to write my square root of 3 off to the right. Now, when I'm dealing with an odd exponent, some of you maybe have realized there's kind of a shortcut to this. The shortcut that I use is I'm going to borrow 1 from 5, and I'm going to make it a 4. And the one that I borrow, I'm going to leave underneath the square root sign. Well, now what I have left is x to the 4th power, and the square root of x to the 4th is x squared, which comes on the outside. So my final answer would be 3x squared times the square root of 3x. In letter C, once again, if you have two square roots and they are actually divisible by each other, you can go ahead and write it as 1. So the square root of 60 divided by the square root of 5 is the square root of 12. And once again, you want to make sure that your answer is as simplified as possible. So the square root of 12 breaks down into the square root of 4 times the square root of 3. The square root of 4 is 2, so we get 2 root 3 as our final answer. And last, let's do one more where we have variables involved. Once again, you want to make sure that they're divisible before you actually write it as one square root. And these are divisible. 80 divided by 20 gives you 4. And x to the 5th divided by x squared would give you x to the 3rd. Because you want to remember that when you are dividing with exponents, you're really subtracting. And 5 minus 2 gives me my 3. Once again, we want to make sure that's simplified all the way down. Well, the square root of 4 is 2. We can write our 2. And once again, when you're given your odd exponent, hopefully you've come up with a shortcut or an easy way to do this. But the way I think about it is I borrow 1. And if I borrow 1, that becomes a 2. The one that I borrow stays under the square root sign. And then I actually have to take the square root of x squared, which is just x, which comes on the outside. So my final answer for that one would be 2x root x.